Hello everyone, today we're going to be going over the complex plane. Now, we have an equation right here, 3 plus 2i. On the complex plane, you need to know two things. Number one, this term right here is like your x-axis. It tells you how left or right you're on the x-axis. In terms of the complex plane, that's on your real axis, okay? This term tells you how up or down you're on the y-axis, or in this case, the imaginary axis, right? So when you're graphing this, we have 3 plus 2i. So 3 means that, because it's not negative, it's positive 3, so that means we're just going to go right 3, right? So 3 right there. And this is positive 2i, so that means you're just going to go up 2i, or just up 2, I should say. So let's make this 2 right here. And so that means that the point, this would be graphed about right here, right? So that's plotting. It's really simple. So now we're going to go over another problem just to make sure that we are very familiar with all the possible scenarios with graphing on here, or at least most of them. So 3 minus 2i. This just means that you're going to go right 3 and then down 2, right? So right here, and that's that. And so another one, negative 3 plus 2i. That means you're going to go left 3, because remember, this is the real axis and it's negative, so that means you're going to go left 3, and this means up 2. So if I make this right here, negative 3, up 2, so that would be plotted out right there. And then one last one, negative 3 minus 2i. This just means you're going to go left 3, down 2. So left 3, down 2. Plot that about there, and that's really it. Now we're going to be talking about subtracting 2 points on the complex plane and finding the difference between them. So let's try to do a minus b, right? So this right here is a, this right here is b. So how would we go about doing this? Well, we can find the equation for each of these points. So for example, the equation for this would be negative 4 plus 3i. Why? Because negative 4 is on the real axis, right? Remember, this is like your x-axis, this is like your y-axis or your imaginary axis, so this means you'd be up 3. So this would be negative 4 plus 3i. This right here would be, first of all, yeah, subtract, put a subtraction sign. This would be 6 minus 7i, right? Because like I said, just apply the same logic like I did here. And so then you would combine like terms and distribute this negative to each term. That is very important. All right, so this would become negative 4 plus 3i minus 6 plus 7i. So then combine like terms, that would be negative 10 plus 10i. And that is the difference between a and b. So a minus b equals negative 10 plus 10i. All right, now we're going to be talking about finding the distance between 2 points on the complex plane. So we need to know this formula right here. Distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Now, we can treat both of these points right here as regular normal points on a regular x and y coordinate plane. So this right here would be negative 4, comma 3. This right here would be 6, comma negative 7, right? So then we would just plug each of the x and y values into this formula. So this would be the square root of, let's see here, x2. So let's make this x2 and that x1. So 6 minus negative 4 squared plus, let's make this y2, y1 right here, negative 7 minus 3 squared. Okay, so then what you're going to do is, this would turn into 6 plus 4, and that would be 10. 10 squared is 100, so this would be 100 plus negative 7 minus 3, that is negative 10. Square that, that's 100, plus 100, and that gives you the square root of 200, which is, I believe, approximately, sorry, that is not an equal, that is approximately 14.142. And so that is how you find the distance between 2 points on the complex plane. Now we're going to be going over the midpoint between 2 points on the complex plane. The midpoint formula, as you may recall from geometry, is x2 plus x1 divided by 2 for your x value, and then for your y value, y2 plus y1 divided by 2. All right? So we're going to be using the same points that we used in finding the distance between both of these points. So we have -4, 3, and 6, -7. Seriously, it's just plug and play. Let's make this x1, let's make this x2, although it really doesn't matter which one you make, you would still get the same answer. So this would be -4 plus 6 divided by 2. And then let's make this y2, let's make this y1. This would be 3 minus 7 divided by 2. And so the midpoint between that would be, or between these 2 points, would be, first of all, this would be -2/2, or sorry, 2/2, which is 1. This would be 1, and then comma, -4/2, because 3 minus 7 is -4. So -4/2 would be -2. So 1 comma -2. And that would be the midpoint between both of these points right here. Now, if you want to put that in standard a plus bi form, that would just be 1 minus 2i. And that is most likely how you're going to be putting that as your answers on your quizzes or tests. You most likely will put it in this form. But obviously, so we can comprehend this concept better, I put it in standard coordinate form, just like how you'd see it on a regular x and y coordinate plane. And so that is the this video on, first of all, plotting complex numbers, then finding the difference between two complex numbers on the complex plane, then finding the distance between two complex points on the complex plane, and then finding the midpoint between two complex points on the complex plane. Thank you so much for watching.